Hi guys, welcome to DQNs Room. Today we'll explain how to train an AI to trade like humans through reinforcement learning. Reinforcement learning is a type of machine learning. The logic is very similar to how we humans learn to play a new game. Let's see the Tetris game for example. We start as a newbie, not knowing any controls or actions. The game is over very soon, of course, with a low score. When we start over, we gain experience and learn from what we have done right and what we have done wrong. When we play it over and over, eventually we'll master the game. When it comes to machine learning, it can finish hundreds and thousands of games in seconds, making it significantly more efficient than humans in learning. Let's further see the major components of reinforcement learning. First, we have the agent, which is the bot we're going to train. Second is the action. It's the agent's decisions to make to interact with the environment. Action space contains all possible actions the agent can choose from. For example, moving left or right or turn the shapes. In the context of trading, the action space will be long and short, and the action can only be one of them. Environment is the game itself, a system which the agent interacts. It provides feedback to the agent in form of rewards based on the action taken. For example, when the agent drops a block, the block will pile up. When the agent stacks up for Tetris, the game will reward the agent with higher score. It is the system behind the game. In trading, this will be the market itself. Depending on the agent going long or short, the agent's portfolio performance and profit will be derived from the market. State represents the environment of a certain point of time. Contains all the relevant information the agent needs to make decisions. For example, it may be the current status of the board, what are the upcoming shapes, etc. In trading, the state is the current and all historical prices, technical indicators, news feeds, etc. Reward is the feedback from the environment to the agent after each action. Typically, the agent's goal is to maximize the reward. The form of reward depends on how you evaluate success for the agent. In the Tetris or other games, typically scores will be the reward. For a trading agent, the reward would be profit or performance, since our ultimate goal is to maximize the money that goes in our pocket. This demonstrates the logic of reinforcement learning. The process starts with the initial state, gathering data like historical prices, technical indicators, key levels, etc. The initial state is then passed to the agent, and the agent, based on the state, will choose the action. The agent only has two actions to choose from, that is long or short. This is the only job of the agent, to assign a value to each action. The higher value of the action is, the higher possibility that it leads to a profit reward. And of course, the agent will always choose the action of higher value. This is called Q-learning algorithm. We won't cover the formula to derive the value here, but all you need to remember is the agent will always choose the action with higher expected reward. The environment will receive action from the agent. The environment will then evaluate the action and return the next state and reward to the agent. Remember, the environment is the market. Therefore, the next state is the market of the next state. The prices, indicators, news all shifts to the next state of the market. And the reward is the profit of the agent. The agent will remember the good and bad trades it did based on the profit and improves itself to make the right decision next time. With enough resources, the agent can go through this process as long as we want, and eventually, the agent can become a good trading bot. Let's try it out. Here to keep things simple, we use 7 years of euro-dollar data for learning. The data used are the closing prices, daily percentage change, simple moving average, momentum, volatility, and direction. This is the learning process of the agent. And here, we visualize the learning curve of the agent. The blue line is the reward it gets in each episode, and the red line is its average. You can see the more we train the agent, the more reward it is achieving. This is the backtest result of the agent. In the learning environment, the blue line is the actual return of euro-dollar, while the green one is the agent's return. You can see the agent has beaten the benchmark by a lot. This is, of course, quite optimistic because it is in a learning environment. The agent has gone through numerous trials. What matters is the out-of-sample performance in the next slide. This graph is more realistic, showing the performance of the agent outside the learning environment. Here, the agent is trading with data that it has never seen before, simulating the real-world trading environment. That said, the agent still beats the benchmark FX. Nice. This is the actual backtest result of the agent. With reinforcement learning, the agent achieved the 8.7% return in the out-of-sample environment. This result is astonishing given the agent is relatively simple. There are many ways for improvement. For example, adding more technical indicators and news feeds to the learning environment, or train the agent with more episodes. If you'd like to learn more about machine learning or practical trading strategies, remember to like this content and subscribe for our channel. Stay tuned, stay degen.